The next thing on our agenda is to talk about functions. And functions in JS are like the heart and soul of the language. So I don't think I have to say it, and it's pretty obvious that this is gonna be extremely important topic in order to understand the entire construct of the language. And the first thing we need to know about functions in JS, that they are objects. We say that everything in JS is an object, and functions are no exception to that rule. Functions, just like arrays that we talked about so much, are also objects. One thing that is very different about them as objects is that they can be invoked. We are calling functions, we are executing functions, and so this is the only type of object that can be called, invoked, executed. We can think of functions as little programs that do something with data or return something or do both, because function can modify the program or can perhaps not modify it and only process elements and return a new value. And we are going to talk about it in a lot of detail, but the return keyword is crucial and essential for this, to return a value. If you want a function to return something, that return keyword is really important. Functions are reusable. So the function can be called and run multiple times. There's like this piece of code that is like a tool you write in once and then you can use again and again. So it should be as universal as possible. They can be used where other objects are used because they are first-class objects. We say they are first-class objects because they have both methods and properties. And so, for instance, they can be assigned to variables, like any other object, as an argument in another function. They can be used as an argument in another function having another function as its argument, or as a return value from a function. So one function can return another function, just like any other object. And that said, I might not feel like it's clear, but I assure you, once we go into examples, once we start like actually coding and talking about what is being returned here and why do you assign this variable here and how this is all connected, this will all make sense. I know that the just theory is a little bit abstract and hard to understand, but let's just try to get a grasp of it. It's like the first step, and then slowly, I'm sure this will become super clear and very natural to you. First things first, how do we create a function? So first, like a way to create a function is a function expression. And say this is the skeleton for the function expression. So for instance, we can use const, we can use something else, but it's most advisable that you use const here. And then the name for the function, it should be like for a variable, it should mean something. You should name the function like thinking about what this function is destined to do. So whenever another person comes in and is reading the name of the function, they already have an idea what this function is responsible for. Or if you come back to the same code a few weeks later or a few months later, you understand just looking at the name what this function's job is. And So got a const, we have a function name, and perhaps this should be spelled with a small letter because this is confusing. Perhaps it might be confusing. We don't name, we just stick to the small letter here, and then the assignment operator, and then keyword function. Function keyword is super important. It's like the reserved word in JS. The parentheses, and inside the curly braces we put the function body. So this is the skeleton for function expression, where you use function, you create function here, and you assign it as a value to a variable, right? And an example of function expression is just below. We have a const called show message, so that's the name of our variable, constant variable, an assignment operator, function keyword, parentheses, and inside the curly braces we have function body, so the block of code that is supposed to be executed when we invoke this function. As you can see, there is no name after the function keyword, and this is called an anonymous function. So this is an unnamed function. We refer to it by the name of this variable that is storing this function as a value. And that's how we call the function, by saying show message. So we use the name of a variable that is storing this function. And that's the concept for function expression. And a pair of braces at the end is as if we were saying to the program, do it. So show message and do it. I'm gonna save it, and you can see that I called the show message function. So there is a console log, and that's the only thing that this function is supposed to do, is just printing the console log message. That is as follows. I call the show message function, and we can do it. We can execute the same function many times. Show message, and the ending it with the pair of parentheses is as saying execute the function now. As you can see, we can do it many times, many more times. If we only do show message without the pair of parentheses, you can get this F that stands for function, so we know this is a function, and we kind of get a description of a function, what it does. So we can see that this is a function, and in the curly braces again we have the function body, so we can see what this function is all about. We're not executing it, we are just reading its description. So we can access the information about the show message function, and if we add the pair of parentheses, this is as executing the function. The other way to create functions is a function declaration, and this is something that we'll practice a lot. We will, in our project, we are going to use all the different ways to create functions so that you get used to all of them. And at first it might be confusing, the syntax, where to place what, how many parentheses, why is this assignment operator here, etc. But for now, the most important is to know that the braces at the end is for executing the function, and soon it will all, like, your system will accept all of it in no time. It's just about writing, typing, and kind of like calling even like the simplest functions. Just to get used to the syntax is like learning the new language, really. So the function declaration, first the function keyword, and then the name. So here we cannot say this is an anonymous function. This is not an anonymous function. We have, like, the skeleton is here. So first is coming the function keyword, then the name of our function. Again, I don't know why I spelled it all with capital letter, and the braces, and inside the curly braces here we would put the block of code, whatever this function is responsible for. And this is just to see how it's built, and this is the actual example of how this looks like. This is an example of like a very basic calculator. Got this function keyword. Again, this is a reserved word in JS. Then add numbers. This is my name. I've created it. You could come up with anything else. You could call it add num, or like anything you want, really. So this is up to you. And here in the parentheses, I'm placing parameters. So something that my function will expect at the time of execution. So here is just X and Y. So these can be thought of as symbols. We're just expecting some values to receive here in the parentheses. And there is this keyword return. Return keyword is also very important here, because you can see that this show message function was only console logging something but not returning anything. And this function add numbers is returning a value. It's going to take X and it's going to take Y as from the second parameter passed, and it's going to be added together. So if I'm going to call this function on line 43, you can see that I'm using the name add numbers. Then again, there's always a pair of parentheses at the end. It's necessary to add them if you want to execute a function. And here, when I'm executing the function, I am passing actual values, something that I want to make the operation on. So under X, it's 2 substituted, and under Y, we have a 4 substituted, and the body of the function is doing X plus Y, so it will take 2 plus 4, and you can see that I'm saving it, and you can still see only the console log from the first function here, or you can see nothing from our add numbers function, and it's because the return when function returns something, it's not like you're going to see it anywhere in the program. If you return a value, you have to do something with that value, otherwise it's just being returned. And well, I'm going to show you that add numbers here, if we do, and pass some values, I don't know, 3 and 6 this time, it's going to give you now 9. So you can see that it's returning 9, but this is just the behavior in the dev tools, in the console of the dev tools. So otherwise in the program, if I'm going to execute my function here, you won't see it. If I'm going to place it here in the console, then you can see that return value. On the other hand, if I'm going to execute show message in here in the console, you will see that the console log has been returned, like has been console logged, but nothing has been returned, because this return keyword is essential to return a value from a function. So this function does not return anything. In fact, it's just doing the console log but nothing else. And that's why there's this undefined, because it doesn't return anything. And this keyword, just bear in mind, is like, just make this like keywords. Remember the keywords, and don't worry if it's so very unorganized in your head and you don't understand everything and don't feel like you could write your own functions right away, because it takes time. Next thing to focus on here is that we have parameters. So we have parameters when we create the function, and here we have arguments. When we're passing the actual value that we want to work on. This is just the kind of like a skeleton as well. So a model, something that is supposed to happen, but anything can be placed under X or Y. And if we wanted, for instance, to make our show message function a little bit more universal, we could also pass a parameter here. So instead of hard coding, I call the show message function here. I can place it in here, remove it from here, and making it more universal by creating the parameter of message. So my function now received a parameter of message and is supposed to print that message in the console, right? I hope this isn't too much, but this is the parameter. What I want to do with the parameter I'm using inside the curly braces in the function body. So here I want to print the message in the console, and here when I'm executing my show message function, you can see inside the parentheses I'm placing the actual message, whatever I want to be printed out. So this is going to be substituted under this message here. Message can be anything. You can change name of the parameter to anything, like it could be still X, but then it has to be X here, and it doesn't mean much if you place an X. Also, it's very good to name your parameters something that you will make some associations with, and it's gonna feel like you understand what it does. But this is gonna work exactly the same. It's just important that if you stick to the X, if you created an X here, you have to stick to the X here. I'm gonna go back and leave message here and change my show message to hi. That's it. That's my message. And save it. And you can see that show message now printed out hi. If you wanted to say anything else, you could. And so this is now more universal because I'm passing a parameter, and here I can update message every single time I'm executing this function. Cool. So a little bit about parameters, a little bit about arguments. Argument is the actual value that you're passing when executing a function. And these are two ways of producing functions. So far, the function expression. So when you create a function by you assigning it as a value to a variable, and a function declaration where you don't assign it to a variable, but you use a function keyword straight away, then the name of the function, and only inside the body of the function. And the last thing, if you don't place the return keyword inside here, the function is most probably not going to return anything, because this is your job to make sure that it's going to return something. This function here is printing out the console log message, but it's not returning anything. Right. So about those two ways of creating functions, there are some upsides and downsides, and it depends on how you look, how you perceive a language. So there are some people who love hoisting, and there are people who do not like the idea of hoisting, and they think this is a bit chaotic, and either everything should work the same way or shouldn't. But as we know, the language, when introducing new changes, has to be backwards compatible. So if something worked this way so far, it's not going to be changed. So if we create a function declaration, so it's all together, rather than assigned to the variable, there is the phenomenon of hoisting. So meaning this whole thing, it can be executed. You can see that the function has been created here on line 49, but already on line 47, right before the function has been even created, I can actually call this function. And you can see that the console log message is here, programming NJS from line 50. So I've executed, I was allowed to show course name to invoke this function before it has been actually created. And so this is how the hoisting works. It will take the entire function declaration and move it upwards on the first reading of the code. We are going to talk in detail when it comes to hoisting as like one of the later classes, but already now know that the hoisting works and it's moving it upwards so that we can execute this function online here before the actual function came into existence. And so there are fans of this, there are some people who hate it, and it's just something that you probably will have to make your own mind about and decide whether you think it's a good thing or not a very good thing, but it's only gonna happen when you a little bit more pro and you do a lot more coding, and then you can decide. Right, I'm gonna comment this out, save it. I'm gonna comment this out as well so we don't have any console log messages showing in the console. And the third way, this is just more of a curiosity I'm showing just so that you are living your life aware of everything, and this is in no way something that I would encourage for you to actually apply, and I don't know of anyone writing programs this way, but you can use a constructor. So like previously we've seen that we can create a new array using the new operator, new keyword, and then the constructor function is always spelled with the capital letter. So array has been spelled with the capital letter and object spelled with capital letter. In this way you can also create a new function. And then to create an actual function body, this is how you do it. So let's say the first thing you're passing, remember about the quotation marks, is a parameter. So this is like we had this X and Y here, or this message here. So the first thing is meant to be a parameter. And the second thing, well, there are many, you can pass many parameters first, and then at the end comes the body of the function. So this function is supposed to have an alert and with our text inside. So this is this pop-up message that comes here at the top with the message that we place as a parameter here. And this is just terrifying. If I had to write my code this way, that I would be I would not feel very good about it at all. It's awful. But it works. I'm going to show you that it actually works. This is the text alert that we've assigned our new function to. So this is the variable, and calling the text alert, and in the parentheses we are passing this first parameter it expects, so some text, and saving it. We can see that there is a pop-up window saying works. We change it to how you doing, then save it, and you can see that it's now saying how you doing. Right, so this works. It's just not a very advisable thing to actually use in practice, but we need to be aware. In order to be a great developer, you need to know of all the weird stuff as well. All right, I'm just gonna comment this out so we don't have that pop-up window every single time. Save it. And so in bigger programs, I would personally recommend the first option. So the function expression, you are assigning to a const. As we know, consts are a very safe way to assign things, assign values, because they cannot be reassigned. So they're always safe. They cannot be hoisted, or the hoisting works a completely different way. So we don't have to worry, and we don't have to think whether we can now execute this function before it has been created or not. It always has to be firstly created, and only then we can execute it. And so yes, so the first way with the function expression, I would say the most optimal for like big programs, big projects. If you, however, work on like a mini tiny project of your own, then it doesn't really matter. Option 1 and 2 are great. Obviously option 3 not great, and it's just for you to know that there's a thing like a new function and creating a function by constructor function. Cool. And that was it until recently, because in 2015 we had a new ECMAScript 6 coming into life, and now we have also the fourth way, which is called arrow function. Many times it's also called a fat arrow function, because the arrow here is the representation, the visual representation of the actual arrow is a fat arrow. Let's face it, it's one fat arrow. So if it's better to remember, you can remember it as a fat arrow function. And this is how it's built. So again, a const function name, assignment operator, and here we have parentheses, no function keyword, nothing of this kind, an actual arrow, and then inside the curly braces, the body of our function. So you can see that the change has been made. Before it was function keyword, parentheses, no fat arrow, and here inside curly braces, the body of the function. So the keyword function has been removed. When I was studying programming at first, I only learned this way, and then every time I was writing something at the very beginning, I would just first, because they said like use arrow function because this is the future, and they were right, because arrow function is most commonly used and it's very nice, it's very transparent, and if you learn for the first time, it's just really, it's not going to make any difference. But if you are kind of set in your ways and you learn that you create functions using a function keyword and then the parentheses and then the curly braces, so I was right every single time. I would write it this way, and then remove function and go forward, adding a fat arrow here, and only then I'll be like, okay, I think this is right. That was supposed to be like this, because my eyes couldn't get around the thing. I was so used to the function keyword, but I guess for you it doesn't really matter. Cool. So this is the difference, and it has a different syntax, so as you've seen, and it has a slightly different behavior. But as I said, it's very common, it's very popular, and it's a very interesting solution. And we'll cover the differences a bit more when we go through the object-oriented programming. I'll mention it when we do our project, because there are slight differences, and they're kind of important with the solutions you're coming up with. But this is not for now, I would say. So the fat arrow function is always anonymous. It doesn't have a name. So you can assign it to a variable and you're calling it by this name, but it doesn't have its name, so it's an anonymous function. The main advantage, especially for now, is that it's much shorter than the traditional function, and it's especially useful for simple tasks. It's like a very quick, efficient, transparent way to deal with like simple tasks, but as you'll see, it's not only for small things, small tasks. It's great for many other things. So here we have an example of an arrow function, and you can see that we've created a variable called show me text arrow function, and we assigned an arrow function here. We have these parentheses. Inside here we are placing our parameter, something that the function expects if it wants to use it in its body, and an arrow, and inside curly braces we have a console log, and we are using the parameter here. We want to console log this text. So it's pretty much like our show message function. It's just written down a little bit differently because it has different syntax. So here I'm executing my fat arrow function, save it, and we should see hello in the console. And so this is the parameter, this is the argument, this is the actual value that we're passing, and this is the syntax. And also one other thing, there's something that I'm gonna repeat a lot as well, as many times as it takes. So it's just gonna become something that you wake up at night and you just know. I'm gonna make it smaller, and you will see that a fat arrow function can be a lot simplified. So instead of like when we only pass one parameter, we can get rid of those braces from here. So we only leave the element that we are working on, which is the parameter here. The fat arrow remains, and then we don't need those curly braces if this is a one-liner. If it all can fit in on one line, that's the rule. You can get rid of the parentheses, the curly braces, and just leave it this way. So hey man, save it, and you can see that it still works. So this is why I'm saying this is much shorter way, because it's only taking like 1, 2, 3, 4 words, and the entire function is ready. I'm just gonna make it bigger again, zoom in, you can see better what's happening here. Right, so we need those braces if we have more than one parameter. So it's like text, and let's say name. If we have 2 parameters, we need braces. If we have no parameter at all, we also need those braces to be there. But if we have one parameter, one element that we're working on, then we don't need anything. Cool. So I'm gonna comment this out and move on to the next thing. Assigning a function to another variable. So functions are objects, and as we said, when we talked about simple data types, we said that when we create another simple data type of the same kind, it's a copy. So they start living their separate lives. But when we talk about reference data type and non-primitive data type, they are called reference data types because we don't copy them, we create references to them. If we place a function, like assign it as a value to a variable, this is not as storing that function inside, even though I'm gonna say, because it's much easier to say this variable is storing this function here, but this is only a link to memory in the program, to some place in the memory of the program. And so since they are objects and not primitive data types, if you do something like this, that you create a new variable, says show new course, and you assign the reference to show course name function, this is not copying the same function that later on we have two of the same functions. This is us creating a link to the same function, not a copy, still the same function. So we can now call this new function, which is gonna be pointing at the same thing. Save it, and you can see that the show course name was programming in JS, and this show new course is also doing exact same thing, but this is not a copy. This is copying like a reference to the same place in the memory. Cool. Again, I'm gonna comment this out, move on. Function call. Right, so we've said it already, but we need those parentheses after the name of our function. We want to call it, we want to invoke our function. We need to use those, and this is us saying, do it, computer, please do it. We can pass some arguments here, but when we create a function, these are parameters. Only the actual values are passed as arguments. So some people use it interchangeably, but parameters are the symbols, X, Y, message, something that is like universal, and the argument is the actual thing, actual value that we are passing in. The created function can be called many times, which we've seen. And we can call the same function like as many times as we like, but it can also be never called. So if, for instance, if you're listening for a click on the button on the website, maybe nobody ever is gonna click that button, so that function exists but is never called. Other values or objects than the function cannot be called. Right, so that was from the introduction, only functions, the only objects that can be called. Alright, now let's focus on this return values from a function, because I've made some points at the beginning, but I'm sure this wasn't clear in any way, and we'll try to make it a little bit clearer as far as we can, because this is still theory, and theory is just a theory. It's the best to learn on actual code, and then things are becoming obvious. So the function can do something and can return something. By default, every function returns undefined after the task is completed, unless we change it. And we often do change it, so we introduce the return statement. Return statement is the key like information here, something that you should remember. It's us introducing the return statement. If we don't do it, like with the console log, the function that is just doing the console log here, we have the first example here, and this function here affects the program, so it has some side effect because there's this console log that will be printed in the console, but it returns nothing because we didn't say return blah blah blah. It's returning nothing, so it only has the side effect of the console log. We say it's a side effect, it's not a side effect, it's just something that we have to learn to control. But as long as if there isn't a return statement, it's not going to return anything. So what this function is supposed to do, it's taking as a parameter a number, and then it's going to console log number divided by 2. So the number is provided by us, and it's always going to divide it by 2 and print that message in the console. Right, it doesn't return anything. And so if I'm gonna uncomment this and save it, you can see that I've passed 10 as my value to be divided by 2. So we have a console log that says 5. And so this comes from line 116. You see, we can see everything in the console. The console will tell you everything. And so this number has been divided by 2. But if and the value of this should be assigned to my result 1. But if I'm going to try to access the value of result 1, I'm going to receive undefined. And why is that? Because by default, if we do not introduce a return statement, function is going to return undefined, unless it's a built-in method that is going to return something. Now this is a different story, so let's just focus on this. We have a console log, we didn't introduce a return statement, and so if we try to assign the value of whatever has been produced by this to our result 1, nothing is going to be assigned here, it's going to be undefined. Return statement, key concept to remember. Have another example here. We have a function, anonymous function again. We've created a variable number with the value of 0, and inside our function we want to do 2 things. We want to increment that number by 1, and we want to console log it. And if I do add, you can see that it doesn't expect any parameter because it's empty here. And I'm adding 1, so I have now added 1 to 0, it's going to be 1. I'm going to do add again, so it's now 2, add again, 3, and you can see that console log is printing the number, every time new number to the console, it's producing undefined. So this is the returned value by default. And we are going for example 2. Let's get rid of this result 1 from here. Well, it's this from here, actually from the console log, save it. Right, and example 2, a function that only processes data, so there's no side effect. It will do something with this data and no producing side effect, but instead it does return a value. So we have a const divide by 3, a function expression with our anonymous function again. It expects a parameter of a number, and then we have that return statement. So we say return and what is supposed to be returned. And you can see that it's not even commented. If I'm going to uncomment and save it, so you will see that there's nothing printing in the console because we are returning something, but it's not going to produce anything as such in the console. So unless we use this value somewhere else, otherwise it's not going to actually do anything. It's not going to stop the program, it's not going to console log anything. There are no side effects. We are producing something instead, and because we have this return statement here, the value produced by divide by 3 is now stored in result 2. So I can print out the result 2 and it's going to give me 6.66666. If I change it to 21 divided by 3, save it and give me the result 2, again it's storing 7. So the result 2 is storing now a value because this simple function here had our return statement. So if the function is returning something, we can assign this value to a variable and then work on it. Just so you will see we can do something like this in the console, divide by 3 and providing the number. And even though we are not console logging anything, the console will tell us what is the returned value. So if you place your executing your code in the console, it's going to show you what is the result or what is the return value. But in the program as such, you won't see it anywhere unless you are using it. So you are assigning it to a new variable. Otherwise, you cannot use it. Okay, example number 3. The function with a side effect and returning a value. So we are not limited to just, either the side effect, you can console log something, or you can return some value. You can do everything. So we have now again divide by 5, an anonymous function here assigned as a value, and inside it's curly braces, so this is the body of the function. We create a new variable inside here called result, and we are passing a value. So this is going to be a value for the result number that we expect as a parameter to be passed in when executing a function, divided by 5. Then we want to console log that result in our console, and also we want to return the result as well. We save it, and now we have result 3 assigned to the value of divide by 3, and as an argument as the value passed here, I'm putting 30. Save it, and you can see both the result in the console. It's coming from line 138 if you were not sure. So this is the console log from here. The return result is not printing anything in the console, but because we have this return statement, we can get this value to be stored by our variable result 3. So if I'm going to do result 3 in the console, we can see that it's storing a value of 6. So I know this is still not clear, and it doesn't have to be just yet. It's just gonna become like clearer, and you will become more comfortable each and every time you're writing a new function and you can see that result. Sometimes you will be like, okay, where is my result and why am I having this undefined? And it will become very natural to you. And I'm gonna comment this out, and let's focus on the parameters and arguments. So I hope that I made this clear, that the parameter is something that the function expects at its creation when we create a function. An argument is the actual value we pass. So we can create functions without parameter at all. We have this my show my name function expression. So it's the function anonymous function is assigned to a const called show my name, and I'm console logging my name. So if I'm gonna call it, I'm gonna see hola in the console. It's not returning anything, so by default this function is returning undefined. So because you can see I didn't produce any return statement. We can have a parameter, so it's concept used when creating the function. Have a parameter called username, and then the username is used in the console log, and the argument is the actual name that we are passing here in the parentheses when when executing the function. So here is Francis, and Francis is going to be substituted for this username here. So when I'm going to hit save, we will see hello, and under username we have no Francis because that has been introduced as an argument. Hello Francis here, you can see. Again, comment this out, save it. For example, in the function above, we set one parameter to create a function. When calling a function, we provide an argument as a value for that parameter. So this is just reiterating what I'm saying the entire time. And also, if no argument is given, you can see that the show username expects an argument, a parameter, undefined will be put in its place. So if we try executing show username and we do not pass Francis or any other name, hit save, you can see that there's going to be hello undefined. So instead of name, like JS is not going to throw an error, but it's gonna place undefined underneath. Like if you don't provide a name, the JS will do, and we just to use undefined instead. If a function expects one argument but you're gonna pass two, it is just gonna be ignored and it's not gonna cause any errors. Okay. And just as a curiosity, because I've never used it, and I don't know if it's a very common thing to use, but I don't think so. Show username.length. Functions have also length property, and they just work slightly different too. Like an array has elements, so we can access its length. We know how many elements are in the array. So it's like a little bit more like maybe common sense. But if we do show username length, paste it here, you can see that it has property length and it has a value of 1. And this is how many parameters a function expects. We only expect one argument here, and so it's printing out 1. So you show username length is how many arguments is expected to be passed as a value for a function. And again, this is something more of an interesting fact, something that maybe perhaps you'll find interesting, and not necessarily that you have to memorize it, and it's just so crucial for your successful becoming a lawyer, a developer. I wanted to be a lawyer, maybe that's why I said a lawyer. Okay, we have like still some more things to talk about when it comes to functions. So this was just an introduction, and I hope your system will accept all those new structures, new syntax. This is like, functions are the heart of the programming language, so it kind of impossible to go around and not to learn them, like and go very deep and understand the syntax and structure. And so those curly braces and other braces and assignment here is not confusing, because once you're given like many lines of code, especially at interview, people sometimes come to interviews and they understand the code because they can read the code. It's like reading a book. They think that if they can read a book, they can probably write as well and type things. But once you're given a keyboard and you don't have your notes to look at, things are becoming a little bit stressful and tricky, and those curly braces get lost and things are underlined and you don't know why. And well, it's not pretty. So just make sure that you type it so many times, which is going to happen when we do our projects, that you will never get confused and you'll be like a laser seeing too many curly braces, and you'll be able to catch the mistake like the IDE. Cool. So I will see you at the next lecture about functions, and let this information kind of be taken into your system. Thanks. We are going to continue the topic of functions, And since this topic is so extensive, there is no way to kind of like exhaust it ever. So in no way this is the sufficient amount of information. It's just we're covering some basics here. The next thing that I would like to touch on is the default values in functions. So something that came with the ECMAScript 6. So it's something that we didn't have before 2015 is that we can, for the arguments or for the parameters that we are expecting for our function, we can set default values. So if we do not give an argument at the point of execution of the function, when we are supposed to pass some arguments and we don't, the function will take the default arguments. So it works this way that we have that function here. This is a function expression. So we've created a const at 2 numbers, which will take, is created using an arrow syntax, arrow function. And here we are expecting 2 parameters, x and y. And I know these are not very good names for our parameters, but it's also for you to kind of not get used to saying like number 1 and number 2 all the time. And it will force you to kind of engage your brain a little bit more, because this is not so obvious. You kind of like have to think harder what this means. I know that it is also more tiring, but you will thank me later. So we have x and y here. Those are our numbers. And inside the curly braces, this is our function body. So we create, inside our function, we create const result that will take a value of x plus y. And it's both, it wants to console log, we wanted to console log the result to our console, and also to return the value of result. We wanted to do those 2 things. And if we want to, let's say, add 2 numbers, we will execute the function and not provide any argument. It's gonna return not a number, because there was no value passed as an argument. So basically this function has become useless. But if we do something like this, say x equals 1 and y equals 3, even if we do not provide anything at all, no arguments passed as values, we will have those default values that will be automatically placed in the place of x and y. And there's some situations where you just want to place either an empty string as a default, not to receive an undefined, because if the user or person doesn't provide an argument, instead there will be a value of undefined here and undefined here. And if you want to kind of prevent this situation, you don't want to ever receive undefined, you can provide those default values. And one thing to remember, for instance, if we have a default value for x, so for our first number, and we don't have a default value for y, if we do something like this, add 2 numbers and then pass, let's say 5, and we would think, right, there is an x that is 1, y doesn't have a default value, so I'm just gonna pass 5 and I hope this is gonna work as a substitute for y. It's not gonna work, and it also will return not a number, because the order matters. They are provided in this order, and so it has to be that the first one is gonna go for the value of x, and only the second parameter or the second argument that we are passing will be going as a value for y, always. This order matters. It doesn't matter that the first one already had a value and the other didn't have a value. If we do the opposite, so we do something like this, and x, it has no value now. Let's save it and let's repeat our code. So add two numbers and we provide only one argument. It's gonna take 5 and place it underneath this x here, because it's gonna take it as the first parameter. So this is okay. It's not okay to assume that if this one is empty, this has a default value, you can just provide one parameter. This is not going to work. I just wanted to very quickly show you the same thing, just written down a little bit differently. So using this other syntax, we have to comment this out. So because the name for the functions is the same, so the program will not accept two same functions, and also because we used const, so this is automatically out of question. So I'm commenting out this part, and just very quickly you can see that here we are not using an arrow function, but the traditional original function way. And again, function expression, so we've created a const called add two numbers, and we assigned the function to that variable here using a function keyword. Here I'm passing my parameters also as default, so providing if no argument is provided, then I'm passing a default value of 0 to x and y, and the rest is exactly the same. So we can see and compare. I'm leaving this in the source code, so when you download this file there will be both ways, and so you can look at them, analyze them, compare. Okay, moving on to the next thing. Next thing I wanted to talk about is a callback. Callback sounds like a very tricky thing, and I will give you a head start. It's like, it sounds complicated. It isn't as complicated as it seems, but it's much better to try to understand it really well from the very beginning, because later on, like for instance, I'm going to use my own example. When I got my job, I wasn't really super comfortable using callbacks, and I will show you the examples of callback in just a second. Then I was kind of like, okay, I get those simple examples. Maybe I wouldn't be able to write my own examples and use them like really comfortably in my own code, in my project. But I thought I kind of get the idea, so it's okay. And then I got my first job, and what I saw, there was a pyramid of callbacks, callback on a callback on a callback, and they were all doing something. And I just thought that if I only spent like some more time trying to understand callbacks and using them, typing my own functions, so that would become really easy on those, at least on those simple examples. Maybe when I go to this next level, I wouldn't feel so frightened and like crying. So I definitely encourage and advise paying attention to the explanation of what callbacks are, and in no way I mean that you should memorize the entire thing. Like as soon as I'm gonna explain it, it's just for you to kind of, the first step is to get your head around the idea, to grasp an idea, and then try to understand what is happening in those functions. Later on, step 2, try to write your own functions and see what is going to be the console log message, what is going to be the returned value. And step 3, move on to the next level of like really complex architecture, because It's just so very common in the programming world. Yes, it's better to make your peace with it sooner rather than later when it's more painful. So, my example number 1 of a callback. We have a function with the name of count created the traditional way, which is receiving 2 parameters. The first parameter is an x, and I'm gonna do that this x is gonna be a number, and a callback which stands for a function. So we are passing a function inside another function as its parameter. The function we pass to the callback function, that is the function passed as an argument to the function. So this is going to be an argument inside that function. And just so you know, when we use a callback function as a parameter inside another function, this outer function here, this is called a higher order function. Something that you might also see or meet with something like this, so you know already that this is the higher order function. And here we passing 2 parameters, one normal, let's say, and the other one is a callback function. So this is going to be another function here. And we return with our higher order function is the callback function. Our callback function is also receiving a parameter or expecting a parameter, which is this x from here. I hope it sounds easy. And we have those 2 other functions here. Whoops. One called add1 and the other one subtract1. So this is like a little bit of, again, like some sort of calculator. So here, the only function that they have is to increment the number and to decrement a number. So add 1 to it and subtract 1 from it. I called it item here just so that, again, your eyes don't get used to seeing always a number for when we're expecting a number, because it can be anything. Of course, number is much better because it's more descriptive, but anyway, we can expect any name to appear here and we should still understand what it does. And also at interviews, they are also being very tricky. So oftentimes they will not use a number, but they will use just some random, I don't know, X, Y, B, Z, foo, bar, etc. And then you just really need to know what is happening inside there rather than make associations that, oh, this should be a number, so incrementing a number makes sense. We can increment an item as well, and you just have to realize that this is going to be a number then. So here we are expecting a parameter, so we are expecting an argument when we execute this function. The function is supposed to increment item by 1. It's also logging the current value of item and also returning the most up-to-date value of item. Subtract 1 does pretty much the same thing, just the other way, because it's decrementing the number, then console logging the number, and then returning the value of the number. And I've created those 2 functions here because they will be acting as my callback function here. So we will go to the line 48 and just have a look what I'm doing here. I'm executing my function count, so the first one from here, as the first parameter. So as an x, I'm passing 5, and as a callback function, I'm passing add 1. So this is my callback function. Here, the second parameter, actually another function add 1, and we can go inside the add. First of all, we go to inside this function here, and it's returning a callback. Callback with the parameter of x, so we know this is going to be an add one, and here instead of x we have an item, and instead of item we have a 5 because we know that this is what we passed as an argument. There's like a little bit of a chain, and that's why it's a little bit hard to make those like connections in your head, but I'm telling you, it's much better to focus now, understand this really well, and so that when you see a pyramid of callbacks, it's not going to be as scary as it was for me on my first day. And next thing we do is that we know that the item is 5, so we increment it, which should equal evaluate to 6. We want to console log our new value of item, so 6 should appear in the console, and we also return this item, so this value of 6. And I'm just gonna save it so we can actually see 6 in the console, meaning that console log item here is 6 now. If I'm gonna uncomment line 47, I'm just like going back to the previous lecture where if we return something, we provide this return statement, we can actually assign the new value to a new variable. So we've created a const result and executing this function. This is exact same function that is on line 48. So we execute with number 5 and a callback function at 1, and the result now should store a value of 6. You can see that it's indeed storing 6. So this is what happened here. This is the simplest example of what a callback is. I'm gonna show you a few more, and those are something that I don't insist that you try understanding now, because we will practice them all in our project. But our example number 2 of a callback is something that you will do a lot and often as a developer. We are using an add event listener method, which is a built-in method. It's already there, it exists, and so you just are free to use it. You can use it freely and for anything that you want. We are executing it on the window. Window stands for the entire browser window, which will also be discussed in the theory at the very end. We'll say a few words about the window, but we are executing on the window our add event listener method that already exists, and it expects 2 parameters. So the first one is the event that we are listening for, and they are already kind of like specified and we can just use them. It's not like something that we've created now. The first parameter is the event, so we are listening for a click, and the second parameter it expects is a function. So this is a callback function, and here I've placed the entire body of that function keyword, and in the curly braces the body of that function, which is console log, maybe instead of hi Ola. Quite like using my own name in the console logs, but let's say just click, save it, and now when we click on the window we should be able to see the console log message saying click, because we are listening for a click on the entire window. You can see this is the callback function here again. And do not worry about the add event listener, because this is something that you either gonna love after this course or you're gonna hate. But we can also take this function out from here and only pass a reference to the function, just like we did here as a parameter. So I'm going to create a show click function, And this is the reference to our function that has to be created above. It's going to be under const show click, and I'm going to paste I'm going to write it. I've copied this, but I erased it, so never mind. So we've got a function that is supposed to do, the only thing it's supposed to do is supposed to console log message of click. Save it, and it should still work exactly the same way. We can see that click is being console logged every single time this event is detected on the window object. So this is our callback function, which is, there it is. This is our function expression describing our function. Example number 3 is another kind of built-in method that we execute on a window. Again, it's called setInterval, and the setInterval is a method that will just a second, it executes it receives a callback as well. You can see that the order is different, so it is not said that the first one has to be a callback or the second one has to come as a callback. Doesn't matter. It just setInterval works this way. It awaits as a parameter, it is expecting a callback function and also time. So the 2000 stands for 2 seconds. So something of whatever showtime is supposed to do is executed every 2 seconds. So function executes, repeatedly executes the code from the showtime at fixed time delay, with a fixed time delay. And as soon as I uncommented the setInterval, you can see that every 2 seconds we have that console log message in the console, and just the number is increasing, 41 now, 42, and so on and so on. And if I'm going to comment this out and save it, it's going to disappear. I'm going to uncomment, reset, and you can see that after 2 seconds the first console log message has shown. And again, setInterval is something that we'll practice a lot in this course. This is only for the purpose of presenting the callback. So again, we're placing a function inside another function as a parameter, which expects a callback function. And even the listener expects a callback function on the second position here, and the showtime is in the first position. And last example for iCallback is working on the array. So I've created again the user's age array, which is an array collection of some numbers which represent the age of different users. And we've got familiar with the for loop. Another way to iterate through elements on the array is a for each method. And the for each method is specifically designed to work on the array. So I'm using it on the user's age. Then by dot, I'm accessing everything that is available to us because it's an array and it has its built-in method, for each being one of them. I'm calling for each, and for each here in the parentheses. So this is the parameter, and what it expects is also a callback function. Here, this is an arrow function, so you can see that there's, normally you see the braces, and as the element that we are working on, we are passing each individual user age. So every element, it could be called anything else. It could be called element, and here it would have to be called element later on as well. But we have to stick to the same name. And normally user's age, as I said, it's plural, so we would single element would be user age. So that's why I called it user age. And what it's supposed to do is supposed to console log user age is, and here injecting, because I'm using the template string. So the template string here helps me to inject the value of the user age straight away, right in this console log. And so you can see that for each is another method to iterate through all elements in the array. So it will take each individual element one by one and then print out a console log message for each and every one of them. So let's have a look. I'm gonna save it now, and you can see that this is separate. Okay, I'm gonna comment out the set interval because it's just not necessary for now. We can see this many separate console log messages. So for every element that is in the array, it's a super quick and an excellent method. And again, this is not, you don't have to focus on the for each because we will practice it later on. But user age is 20, user age is 30, and for every single one of them, we've got this console log message with the user age updated every single time because it iterates through every element. And again, main thing that I wanted you to focus on is this callback function. So the for each is a method that we will receive as a parameter a callback function. And here I used an arrow function and also wanted to show you the traditional function. They can be active at the same time because they work independently even though they do the same thing. So here we use a function keyword. In the parentheses, we are passing the parameter that we are expecting. And again, for each is making sure that it takes each element from this user age array because we are working on the user's age, so it knows to take, it has to take each and every element from this array. And we're doing the console log here. I use the concatenation, also the traditional way with the quotation marks and the plus here, and printing out exactly the same thing. So it's printing out twice, once from the arrow function here and the second time from the traditional function. And we are executing on lines 73 to 75. Our console log on line 74 here, you can see it's coming from there. And this is all about the callbacks, because just so you understand that we can use functions as a parameter, but to go into specifics of everything, the for each, the set interval function, the method of add event listener, this is all something that we'll practice so much more. So do not worry about the details of those just yet. The time will come. The last thing I wanted to show you about really quickly, because this is, I don't feel like this is a very important topic. It's just also very good to know. It's always good to know everything. So it's sometimes hard to choose what is more essential to know than like this. The argument is an object. It's a built-in object. It's available to us for us to use. It's not something that I've seen being used very often. So that's why I don't place the importance of it really high. But it's similar to an array, but it's not an actual array. It's an array-like object. It contains the actual list of all the arguments passed to the function. And the first function, show arguments, has been created only to present what the arguments are. So as you can see, I've created a show arguments function with the function keyword is a function expression, and here I'm executing it, placing 3 arguments. Our function doesn't expect any parameters. It doesn't specify, give me 3 of name, of a number, of age, nothing. But sometimes we create those kind of functions that you don't know how many arguments and what kind of type you will receive, and those arguments sometimes become handy. And so the first console log is to show what the arguments are in general. The second console log is to show the argument's length, because arguments have the length property, so we can know how many arguments have been passed. And the next console log is to show you that we can access every specific element, every specific argument, given the array-like notation, so the square brackets and indicating the position, the index. And the next console log is to show you the type of argument, and the last one just to check if it is in fact not an array. So I'm gonna hit save now, and we can see everything has been updated in our console. So first of all, we console logged arguments. So we can see that the argument is like array-like object. We can see position 0 is all at position 1 is null, and position 2 number of 9. We can see that it has a length property of 3 and the prototype of object. If we open this, again, maybe you won't see it, but I'll tell you that there are no methods available to an array. If this was an array, we would see many more methods available. So this is an object, an array-like, because it has its length and the positions that can be accessed, but this is it. Then next console log, I85, the first one, call argument length. We can see it's 3 arguments provided. Then in the next console log, I'm trying to access the element that is stored in arguments position 0, which is a string of Ola. Then type of arguments, do you remember the operator type of? It will return an object. But because even if we check the type of an actual array, it will also return object. So just to be sure, I've used this isArray method that you might remember from when we were doing the introduction to array. So I'm using the object array, then it's built in the method isArray, and as an argument, I'm passing our argument. And in fact, it returns false, meaning this is not an array. And it doesn't matter how many more arguments we would add here, like more numbers or strings or letters, I don't know, it doesn't matter. We would always get up-to-date information with this argument object if we needed to. And sometimes we need to, and I'm just gonna go also really quickly through this use in practice. Just gonna comment this out. Got a function called add all numbers, and again, this is a function expression. A function created the traditional way with the function keyword, anonymous function, inside our function, we create a variable result with the help of a keyword let, because we want to update it every single time. And at the beginning, we are setting it to 0. So the result is 0 currently. And then something that you are already familiar with. So the for loop, we create our iterator, we initialize it with the value of 0. Then we want to go for as long as we have more arguments, so as long as the argument's length, and we want to increment by 1 each time. And then we want our result to be updated with those arguments every single time. So the result here is as if we said result equals result plus the current value of arguments. So the arguments in the square brackets I will always be substituted with a new number. So it will be like, because this is almost like an array, but not quite, but it has its index. Every argument has its index. So incrementing this I here will increment the index, will allow us to access every argument from this array-like argument object. So this I'm going to comment out just as a mini revision here. And here, let's say we created this add all numbers because we wanted to gather some sort of information. Let's say it was users' money, but we didn't know how much money each user will bring. I don't know if we should count users' money, but let's imagine that we can, and our users are bringing money, but we never said how much money they have to bring, so it's like a free donation, and we don't know how many of them will come, so we don't know how many arguments we will have. So we are looping over all of them, because arguments length, it doesn't matter how many more numbers we are going to pass as arguments, it's always going to be up-to-date length and iterating through every single element in the argument. Cool. So if I'm gonna now access the user's money value, it's gonna give me 209. If I added, I don't know, 45, 21, and 8, save it, it will be very universal because it's always accessing the most up-to-date information about those arguments. And you can see that sometimes you don't know how many arguments or how many parameters you would have to specify here, because sometimes it's very random how much data or what kind of data you will receive in your program. So this is an example number 1, and we can also, this is to finish off the topic, we have how to make a function behave differently with different arguments. So let's say we have a show info about the user, and we are expecting age, name, and her or his sex, but we don't know if they will provide this information. So what we can do, we can create if statements, and you can see that the if argument's length equals 0. So these are the parameters, but so this is what we are expecting to receive, but it's not like certain that you will get all of this information. How many arguments or what kind, this is not a certain thing. So we can do some things to prevent ourselves from like not getting the exact information that we are expecting, saying that if the argument's length is 0, then console log this message and exit, stop executing the program. If we receive one argument, say that the user age is something years old, we don't know anything else. If the argument's length is 2, so we have age and name, then the user is, 12, and the name is Savannah. Else, console log, and this is a complete console log message with all the data. So show info about user. If we provide no arguments at all, the first console log message will show. If we provide some information, and as you know, the order matters, so let's say that the age is first, it has to be first, save it, not save it, cancel, enter. The user is 21 years old and we don't know anything else. And then 21, the second was name, so let's say Sarah. Can execute. The user is 21 and the name is Sarah. And the last one, we can also provide the information that she is female, enter, and user is 21 and the name is Sarah and she is female. Cool. So this is like an example of how or why would you ever need to use arguments, but there's also a better way, and I'm gonna say about this better way, I'm gonna tell you about it in the next video. Cool, I'll see you then. So this is our last video regarding functions. In the previous one we mentioned something called arguments object, and I said that wasn't a perfect solution, and also what I'm gonna add today, that it's an obsolete thing to use. Since the introduction of the REST operator with ECMAScript 6, we had just something so much better to use, a much better tool. So basically the arguments object has been useful up until then, when we didn't know how many arguments to expect for a function to receive. So there was an unspecified number of parameters, and if we wanted to do something like access its length or access an individual element passed as this argument, we could go with an argument object. And now we have the REST operator, and I'm just going to show you how it's different. And it's best explained on the example. So I've created this function here called show all arguments, meaning we don't know how many arguments there can be. It can be 0, there can be hundreds, 10, 20, and as a parameter I'm passing, you can see that the 3 dot notation is like the most signifying thing of the use of the REST operator, because the name can be just anything. I've decided to go with args, which is short for arguments, but it could be anything, all up to you. The most important is to use those 3 dots, and the program will know that we want to introduce a REST operator here, which what it does, basically, it's as if we said to the program, take all the elements that you receive, and it doesn't matter how many of them you find there, take them all, split into individual elements and place in the array. So it creates an array of those objects, or of those elements. Maybe I shouldn't say objects, of elements. So this creates a new array with all the elements that are passed as arguments to our function here. What I want this function to do is just 2 things. I want to console log the args array, and also I've created a return statement also returning the same array. So I'm gonna uncomment line 9, which is me calling the function. So I'm gonna save it, or you can see that it produced an array consisting of 6 elements. You can see that we have 6 arguments passed here as values. And inside we can see that there are also indexes introducing the position of every individual element. There is a length property, and there is also a prototype pointing to an array. And this is key difference between the arguments object and the REST operator. The REST operator will create a real array. We have all of those beautiful methods that we can use on our newly created array. And maybe it doesn't sound like super significant at the moment to you, but it really is a huge difference, because with data that you receive, you normally want to do something more than access its length or only access like individual element. And all of those methods, they make it possible and easy as well. So if we did a console log of arguments, argument is a reserved word, so it always has to come as argument. And I now saved it. You can see we've received 2 of very similar things. So we've got an array and something that looks like an array, also consisting of 6 elements. So we've got 6 elements here and 6 elements here. Also, we can see the index 0 up to 5, the length property, but the prototype is pointing to an object. And object doesn't have all of those methods that the array has. So it doesn't give us all of those possibilities and all of those options that we have when we use the REST operator. And we can work with them like on a totally different level. Right. If we want to access an individual element, let's say index 1, I would do exactly the same thing. We receive the element, the value of 2, this from position 1, and the same for the other console log. So both will do the same thing. So if it's only about those basic functionalities, then it really doesn't matter which one you would use. But if you want to do some more complex, some more advanced stuff with your data, then the REST operator just like definitely think that you should go for. To sum up, the REST operator, multiple elements given as arguments to one array, that would produce a new array with multiple elements. 3-dot notation and the name. Name is up to you. It's an arbitrary decision, totally up to you. Just you have to follow the same rules for that are for creating a new variable. And it returns an array, and argument is not an array. So this is the biggest difference. A real array and not a real array. So I'm gonna comment this out, save it, and let's move on to our next function that is called add all words. Again, here as a parameter, I'm passing something as a REST operator. Here I decided that I want to call it words. So this new array will be called words. And what it does, because again, we don't know how many new words will be added. They can be 0, but they can be 25. So inside our function, I'm going to uncomment this. We have created a variable text, which is currently set to be an empty string. Here we can practice our for loop some more, and our for loop, after it's being initialized and set to 0, it says go as long as you find new elements in the words array. So the words length would return always the most up-to-date length of this array, meaning as many arguments as you would pass, it would always be true. So something that is just taking burden off our shoulders, because we don't have to worry how many of those arguments will be passed, how many more new words will be introduced. And we say that we want to iterate one by one. So just take every element one by one from this array. And this is creating a very long string or a very short string of words, depending on how many of those words were passed as arguments into our function. And to make it easier on the eyes, this is exactly the same. So we have a text variable, which is this one, which is currently an empty string. On the first iteration, it's going to be an empty string, and we want to concatenate the first element. So this is an array notation. We say we want to take index 0 from array words. So on the first iteration, the I is going to be 0, so it's going to take index 0, the element with index 0. On the second iteration, this is going to be increment to 1, so the I is going to stand for 1, and we are going to concatenate to the text that is going to be already consisting on the first element. We are going to concatenate to add another string with the index 1, and so on and so on. And I've added this hyphen here because I wanted to separate the words with a hyphen, but you could maybe perhaps do a white space, but up to you really. And at the end, when we leave the for loop, the body of the for loop is finishing here, and at the end I just want to console log the string. So here I'm executing the function without any argument passed in. I'm gonna save it. We can see that it has been executed, but the string is just an empty string as it was at the very beginning. So that's it. The array has been created, but an empty one. And if I'm gonna execute the function, the same function, but with some arguments passed in, so we have me, you, we have number 2, and also Gdańsk as a string, which is a city in Poland. Save it. I am getting 2 of those because I didn't comment line 16 out, so save it again, and we can see that all of the words have been concatenated, added to an empty string at the beginning here, and the text now is represented by this long string here. If you wanted to be like super perfect and you wanted to get rid of this hyphen at the end that also has been added to Gdańsk, we could go inside our for loop, create an if statement saying that if you hit the last element in the words array, then do not add hyphen anymore. But we are not going to create this condition here because this is not the subject of our tutorial here. We are here to get to know the REST operator. And so what else I can show you here? We could practice our for each method that has been introduced the last time when we talked about the callback. And so for each is specifically designed to work on the array. So we are going to work on the word array that just has been created out of those words here by our REST operator. And we are passing for each because we want to perform this method, opening the parentheses, and inside for each is expecting a callback function. So I'm gonna go with an arrow function. And well, we know that we need to work on one individual element one by one to iterate through them all. So I'm gonna say a word, singular of words. So it's easy to understand what is happening here. And we are going to do the same thing. We're gonna refer to our text variable and we're gonna do plus equal word and add the hyphen. Cool, so I'm using a concatenation again and save it, and the result should be exactly the same. You can see that me, you, tu, and Gdańsk have been produced now again, coming from this for each, and we can refactor it even further. We know that if there is only one element passed, we know, or maybe we don't know, but we are definitely going to learn that if there is only one element passed to our arrow function, we can get rid of the braces. If it's just a one-liner, we can get rid of the curly braces and place it on one line. This is now, the semicolon is not needed, and we can either place semicolon here or we don't have to. We can? Yes, we can, but we don't have to. And save it, and you can see that the same thing that we did with our for loop and concatenating words to the text is done in a much easier, faster, neater, and even more transparent way. So I said arrow function is amazing for simple tasks and very easy to read, and that's probably why this is so popular. And it's also like the reason why the more advanced you become, the less lines of code you write, because you're finding ways to write something that normally would take you 4 lines to just put on one line, and it will do exactly the same thing. So once you become senior, obviously like you'll come to work, write 7 lines of code, and you'll be done for the day. And one more thing to pay attention to, here the for each is already created in a way that is supposed to take and iterate through the entire array. So we don't need to specify the index here, because this word here is the parameter that is going to be substituted by every single element here. So we don't need to introduce the index. That's how the for each works. Okay, so I think this is something we've exhausted the topic on, and let's move on. Thanks to the rest operator, we can collect the remaining arguments which have been placed outside the parameters. So there will be occasions when there are some parameters that you are expecting and you will specify, and the rest might be something that is changing, that is fluid, so something that you don't know how many of to expect. And so, for instance, I've created this function here that's like very vivid, easy to understand, and you are organizing a party, or there is a party being organized, and that one person that will show up for sure is the owner. And as far as the guests are concerned, we don't really know. They can be, you know how it is with parties. They can be, we invite them all. Some of them show up, some of them bring extras, etc., etc. We don't know how many of the guests will actually show up to the party. So we have, first of all, the one parameter, or the parameters that we know of, we need to put first. So the owner is the certain parameter that we are expecting, and we don't have any guarantee of any other parameters. So here we create an array for all others, right? If we had another parameter that we know that we have to be very specific about, it would have to come as second, right before the rest operator. The rest operator here has to come at the end. And then this might look a little bit complex, but it's for us to practice 2 things: a template string and also a ternary operator. So as a console log message here, can see that I'm opening a template string with the backtick. At the party, there was owner. It has to be like passed as a value as an argument. And then this is us injecting the value of the owner directly in that console log. So we're using the dollar and the curly braces. And inside here, we can pass our variable. And this whole thing is a ternary operator statement. And we again are using the dollar sign and the curly braces. So we say others is the reference to our array, which is going to be the arguments passed after the owner, and dot length. We know that the value of 0 is a falsy value, so if it's evaluated to 0, it's going to be false. If there is at least one guess from 1 onwards, upwards, it's going to always be a truthy value, so it's going to evaluate to true. So if this is true, we place a question mark, and the first value that is going to be passed over, so this entire thing here, is going to be executed if the statement is evaluated to true. Then we have a colon, and after colon is what is supposed to happen if the statement has been evaluated to false. Right, I know it might not seem, but it's also something that is going to take it to a higher level, and it's just much better to make your peace with it now and kind of get your head around this idea, how to write it, and you will be grateful later on that you've just spent some time analyzing this, writing it, and getting used to those curly braces and backticks and where each character goes. But I'm maybe making it smaller. Nah. Cool. So the first execution of the function, I'm just passing one value. One value is always going to take the space of the owner. I'm going to save it. And you can see that at the party there was Adrian and a dot. This entire statement, so at the party there was owner that has been passed as Adrian, and later on we were evaluating the ternary operator statement. So this is a conditional, says others length, since there were no other arguments passed, it evaluated to 0, which was read as false. Since it was false, it went straight away. It ignored the value, the first value up to here, and it just read this value from here. So there was only a dot after the owner, so it just placed this dot here. On the second execution, I'm going to uncomment the calling of the function on line 32. I'm going to hit save. So I'm going to execute this function, and we now have also another parameter passed over. So we have Adrian. At the party there was Adrian, which was pasted here for the owner, and then others length evaluated to 1 because we passed one other argument, which was Damien. And instead of going straight away to the dot, it read the first part of the statement. So it printed there was Adrian and plus others, and others, in this case the array of others consisted of only one element, which was Damien. If we do another one and we say Fiona, we'll see something like this. At the party there was Adrian and Damien, Fiona. So I know this isn't perfect because we have a comma here, etc., but it's about getting the idea how this works. So I'm going to leave it for now. And just one last thing, and not a very difficult one, fortunately, the distinction between methods and functions. So we often will hear people use interchangeably methods and functions, and it's not like they're wrong, although they are not correct. So functions are methods, but no. Let's present on the example because I also don't want to get more confused. It's like methods are functions inside objects. So whenever we execute something, like for instance here I say we're working on the array and we are using this for each method. So for each method is a built-in function. It is a function because of course it is a function, but it's a method because it's built in for the array. We don't have to worry about what is happening underneath. Somebody else took their time and wrote the body of the for each function, and we are just free to use the for each on the array. So every array can use the for each, and we don't have to create the body of this function. When we have to create a body of something, this is a function. Also, not going into too much detail because we will talk about objects in the object-oriented programming. This is an object example. Here, an assignment operator to our const, and here in the curly braces, this is the object literal. So we created a new object, and here we've created two functions which are methods because they are available to us to use on this object. I'm going to remove this, and this is the older way how we created functions inside objects, meaning methods, and this is the newer way to create methods. And this exists on the object example. So this exists only on this object, and since it's not like globally available, this is called methods. Methods are inside objects. Functions, here is an example of a function. This is like globally available function, and it doesn't exist as a property of an object. You can see that it doesn't belong to any object here. So for instance, if we wanted to call this show name method, we wouldn't do the same thing as in here. Here, if we want to call this method, that would be just calling a method show name and the perf parentheses, which is like, please do it. And we can see that the console log John showed up in the console, and this is what we are, or maybe we are kind of familiar with at this point, or at least we should be. And if we call a function that is inside an object, meaning we're calling a method. So it's like with the array object, we are accessing the object example, and then by a dot we get to everything that is available to use from inside that object. And here I want to call a show name method. So I'm going to do this, save it, and we can also see John. Maybe I'm going to change this name to Johnny. Save it, or you can see Johnny printed in the console. But this is the way to get access to this function here, and that's why this is called a method. If we wanted to do show age, again, we would work on the object example, const and show age, then the of parentheses because we want to execute this method, and save it. And we can see that the console log is 30. This is a different way of accessing. This is a function and this is a method. So you can see that every method is also a function, but not every function is a method, because methods are inside objects. Cool. So this is like just to get the basics right, some introduction of something that we are going to talk in so much detail later on. And this is just a mini intro.